Okay, thank you. That fixed it. So as the slide says, and as Sanjog also said, I'll be talking primarily about the private blockchain. The URL that you see at the bottom of the page, that has lots of information that you might want to go look at your leisure. It's got PowerPoints and videos and more importantly, I would say papers, both research kind of papers as well as white papers and so on that get into more of the nitty-gritty details as well as big picture and market share, this and that kind of information. In terms of the whole blockchain space, of course, the world got going with it when this fictitious person published a paper. We don't know who the real person is. And that was the genesis of Bitcoin. The underlying data structure for Bitcoin is the blockchain. And it's that data structure that's of greater interest to us than the notion of Bitcoin or all its variants that have come out since then, which are these so-called cryptocurrencies. That work was done in the context of what are called open blockchains or permissionless blockchains, where anyone, anywhere can willy-nilly come and go and participate without necessarily revealing their identity and things like that. And that has led to all sorts of illegal activities and such, as well as many other ramifications that come from the fact that there's no limit to how many people can at any given time participate, and hence the awful performance with 7 transactions per second, 10 minutes for a transaction's outcome to be known. Even that is a more probabilistic statement, not a 100% guarantee that if somebody thinks their transaction committed, it necessarily would be ultimately committed. So we are trying to go away from all that and put some order to this chaotic state of affairs. You will hear the proponents of the open blockchain saying all sorts of things. It's going to solve the world hunger problem and things like that. Don't believe much of it. It's a lot of hype, and there's way too much of a cottage industry based on that thing, both in the research community as well as even the startups and such. But the one that's of greater interest is the so-called permissioned or private blockchain. Don't get confused. Private doesn't mean it's non-open source. This is another problem that people have. They think open blockchain means it's open source. Non-open blockchain means it's not open source. That's all orthogonal points to be taken into account. All sorts of people across the globe are working on various aspects of such systems. In terms of how real it is, there are already production deployments, and you have some more details about what sort of production deployments have happened. More than a year ago, there was a production deployment for managing private equity. So the transaction rates are still not what I, as a database guy, would have been excited about. It's not like the Transaction Processing Council benchmark kind of numbers, tens of thousands of transactions per second and so on, or million transactions per second for that matter. But in terms of worldwide interest, the Chinese companies are also now in a big way into this. You see some more details over there. In the US also, Oracle has announced, but not yet made available, a blockchain as a service offering. IBM has had one for now more than a year based on the Hyperledger Fabric. I'll get into some of the details of that. Meanwhile, Microsoft has published something called the Cocoa Framework. You will hear more about some of the things that I've listed here as part of the panel discussion we are going to have in about an hour. There's also a benchmarking project that's just been launched as part of the Hyperledger Consortium. I don't think we are going to discuss that in the panel, but it's a very brand new activity. But there's some research work that's been done along those lines, which are similar. I'm getting some kind of feedback. Is anybody else? Okay, I think it's better now. There is a benchmarking paper that's been written by National University of Singapore people. In terms of the market share, market size, it's expected to be pretty large. The exact number doesn't matter, but as time goes on, you'll see more about such things. The kind of problem we are trying to solve is one where multiple organizations are working together, but in the good old way of doing things, each of these organizations has its own set of software that they have written or bought from somebody else. And there is a lot of chaos here because each of the systems, each of the nodes in such an multi-organizational workflow has its own database, and there isn't a single source of truth. There can be a lot of inconsistencies between these databases. Even if they are all communicating electronically, these are typically point-to-point communications with MQ messages or EDI messages and so on. This leads to a lot of inefficiency. It's quite expensive in terms of time as well as money. There are still a lot of paper documents being used, and these are all subject to being manipulated where other people cannot detect that something was changed from the original value to the current value because somebody wants to shift the blame to somebody else if something went wrong and things like that. So there's a whole lot of lack of transparency and such things that are associated with it. Lack of transparency doesn't mean the whole world needs to know, which is one of the problems with the open blockchain. Whether you want somebody to know or not, they have the access to that information in an open blockchain. Whereas here, we want only the parties that are working together. So the permission system means only the people who are permitted and who have a business reason to work with one another will be admitted to the blockchain network, and hence they are the only ones who are privy to what's going on. And even within that context, it turns out over time, it's come to our attention that we needed to provide additional functionality whereby even subsets of the people within the network might want to have their own channel, as we call it, in the fabric. And so there is even more degrees of isolation and such that's been desired, and hence they have been provided. So in the blockchain way of doing this work that's depicted in the previous picture, you will have what is on the right-hand side, which is a single source of truth, which is replicated across all the nodes, and it's the same set of programs that have been collaboratively generated that will execute on all those nodes, and this is the so-called smart contract. So it's totally different from the chaotic way in which individual nodes dealt with their version of the truth, if you like. And on top of it, leveraging things like cryptography and certificates and such, and also this hashing that you'll hear a lot about in the open blockchain way of doing business, allows you to do things in a way where you can keep precise accounting of who did what when and who agreed to doing what and so on. So later on, they cannot claim that they didn't agree to it and things like that. So the good aspects of the open blockchain have been adopted, but other things have been introduced to reduce the scalability problems and the security aspects and all that, or the visibility aspects of the open blockchain. So IBM, as I said, has a blockchain as a service offering that comes with what you see there, which is the fabric, which is the base platform, and top of which there is a new kind of software that's been introduced, which is also an open source project under the Hyperledger umbrella called Composer, which allows you to more easily develop blockchain applications that run on the fabric. And there are other things which are not necessarily part of the open source version of the blockchain ecosystem that are specific things that are available on the blockchain as a platform. And this whole thing runs in a secure way because it runs on the mainframe with specialized support for secure execution. We might hear some of this also in the context of Intel later on. The IBM one winds up having much more powerful facility because there aren't any real limitations on what all can run under that secure execution enclave, which means that nobody can tamper with the code or the data that's being exchanged. Nobody can listen in on the data, not even the operators of the systems on which this is being executed. There are many players in such an ecosystem. Similar to in a database system, you have database administrators, system admins, application programmer, and so on. In this context, there are roles like a blockchain architect, blockchain developer, the network operator, which in this case is IBM. If you go and get what Oracle is going to announce, then it'll be Oracle, and Baidu and all these other guys also have similar things. And then you have the blockchain user. So you have to distinguish between organizations which have certain roles and responsibilities and privileges. And then within those organizations, you have individuals who will be having privileges about what blockchain transactions that they can execute and things like that. And you still have traditional backend systems which have a role to play. You might accept an order through the blockchain way of doing business, but the fulfillment of the order might have to involve SAP system or some manufacturing system and things like that. And hence you see the references to traditional data sources and transaction processing platforms. On top of it, you might also have regulator kind of entities, SEC, FDA, and so on, being part of such a network to police what the heck is going on so that the laws of the land are being obeyed and things like that. And you have the membership service, which is the one that's responsible for issuing certificates, and that's the one that has to do with the permission nature of a private blockchain. And that's the one that will say who can do what and which organization can do what and things like that. So the composer software that I talked about allows you to define the different elements of a blockchain solution, which have to do with things like the assets being managed. This could be diamonds, it could be packages, it could be containers and such, or food items that are going through a certain supply chain, which ultimately results in some food item being being produced and consumed and so on. And then you have the participants, the different people who have roles to play in this kind of a solution, who they are and what they are allowed to do and such. And then you have the transaction registry. These are the transactions that allow you to do state transitions on these assets that are being managed. In the case of diamond, it could be mined, and then it's polished, then it's broken into multiple diamonds, and then you might sell it in wholesale, retail, and then a single diamond gets mounted on a ring. All these are different transactions, and different people will have the privilege to do these things or not be able to do those and so on. And you can also have ways of linking, in the case of physical assets, the actual physical asset with the digital representation of such an asset. It turns out in the case of diamond, the picture of the inside of a diamond is very unique. It's like a fingerprint. And that can then be used as a way of figuring out when somebody might have substituted a fake diamond for the real one. In the case of course, purely digital assets like music recordings and videos and so on, it's a lot easier to deal with them because then you don't have to do this comparison with the real world thing and the digital representation of it. And you also have the developer who develops this model of this particular solution scenario, and also develops the transaction logic that actually encapsulates the rules of engagement amongst the different participants. This is what is at the crux of a smart contract. The completely coordinated way in which things have been agreed upon as to what all needs to be looked into and whose agreements is needed for a particular state transition to be done is what makes this way of doing business very different from the traditional way in which business process management systems or workflow management systems might have done it. Plus the fact that you are leveraging all these certificates and such, and also hashing and so on as a way of detecting when somebody might have tampered with some piece of information, and hence you can say, hey, this is not the original piece of information. The point that's typically made that it's immutable, you should very carefully take into account. It's not that the database in which the states are being managed itself is immutable. That can be perfectly mutable, in-place updates can be done. It's the ledger or the blockchain in which the state transitions are being captured as they happen. That is immutable, meaning it's an append-only data structure. Oftentimes people get confused between the two. The state database can be perfectly mutable. It's the recovery log-like data structure, which is the blockchain data structure, that is the immutable one. In terms of use case scenarios, they are all over the place. The green names represent actual organizations with which IBM has been working, as well as some other people and so on. And some of the ones that are listed here are actually in production usage. The diamond one is that Everledger one. That's been in production usage now for more than a year, I believe. And then there is also the IBM Global Finance, that's IGF, Trade and Channel Finance, that's been in production usage. There's also Secure Key in Canada for Know Your Customer, that's been in production usage, and so on. There's a book that came out 2 years ago, which has characterized this whole phenomenon of blockchain in terms of what potential it has to do with respect to common man, not you and I as geeky people, that it's like the second coming of the internet. As much of the kind of impact that the internet had on ordinary people is what ultimately could happen if blockchain technology gets widely adopted in various segments of society, not just in finance. That's an important point to keep in mind. Too many people think that this has relevance only in the finance sector. That's not true. In terms of how the work has been done, it is chaotic at this point because even at the conceptual model level, there isn't any commonality across the different blockchain systems. The one good thing compared to, let's say, NoSQL is that in the case of NoSQL, each of the organizations that developed a system had its own API, and there are gazillion organizations doing that. At least in the case of the blockchain systems, most of the work is being done in the context of consortia that have been formed by a bunch of organizations, not just companies, but even nonprofits and so on have been members of such organizations. And the latest kid on the block as of a year ago was the Enterprise Ethereum Alliance, which is taking the open blockchain version of Ethereum to the private blockchain domain, and you'll hear more about it later in the panel. Don't be carried away if you hear such and such an organization is part of one of these consortia, hence that must be the winning horse because I have more trust in that one organization. Guess what? People are so uncertain about which are all or which one will be the ultimate winning horse. So many organizations, including Intel and JP Morgan, are members of multiple consortia. So they are hedging their bets by being part of multiple consortia. At this point, the APIs and such are different for these different blockchain systems that have been developed under the umbrella of these different consortia. With respect to many architectural features for the geeky people in the audience, there are different choices that have been made by these different systems with respect to, for instance, whether or not Byzantine kind of problems are being dealt with. This is the one where people intentionally try to mess up the system. These are not ordinary kind of failures like node failure or disk failure or link failure, which is the typical three kinds of failures that Mohan and his ilk have dealt with forever. But the Byzantine kind of failure has been talked about for a long time, but the community in the open blockchain world has taken this to the limit, and they have become so paranoid about it, they have messed up regular performance, worrying so much about the once in a blue moon kind of problems that might crop up when there are some bad players. That particular aspect is not so important, I would say, in the case of private blockchains, because you know the identities of the people who you have admitted into the network. And it's not like some random people are just joining the fray. You're going to involve them only when there is a business process that they are part of. And since you know their identity, this is no different from Uber or Airbnb kind of situation where the organizations know who they are and their whole life history probably they know. And under those conditions, there are still people who will try to get away with murder literally even, and then they get nailed and they get booted out of the system. So similar things can be done. So you cannot go overboard in trying to worry about Byzantine failure or behavior, and in the process for the more common situations, get into situations like 7 transactions per second and so on. That's just not realistic. We don't stop walking on the road just because accidents could happen. We don't put armor plate around us just because of that possibility all the time. So we do take chances anyway. So in that sense, there are other issues about exactly how you decide when to add a new block of transactions, who gets to add a block of transactions, the so-called consensus protocol and so on. There are variations of that, like the proof of work that I mentioned before. There are others that people have done, and even in the fabric, for example, practical Byzantine fault-tolerant algorithms was used until the latest release. It's PBFT that you see there. In terms of what kind of database you use, whether in the state database you keep only the latest state of the assets that you are managing, or you even keep the historical state, all of these are variations that are different in the different systems that you can hear about if you go into the lengthier presentation of mine or anybody else's presentation for that matter. At this point, there isn't a real systematic study of all these variations that are there, and real justification of why some system chose to go with one choice versus some other system going with another choice and so on. There is a survey paper that I have referred to there. You'll see the full-blown reference in the link I gave you at the beginning that goes to, at least gets around to cataloging what system has which feature and so on. Not necessarily justifying, because the authors of the paper don't have the luxury of interviewing all the people who built these other systems. In terms of Ethereum, that's the generalization of what the Bitcoin guys did, which went from just managing one kind of asset to managing any kind of physical or purely digital asset. And they introduced the notion of smart contract, but it still has many of the problems of the open blockchain approach as originally proposed in the Bitcoin architecture. And they also introduced their own cryptocurrency called Ether and a notion of gas for charging for the work done. But the more interesting thing, in my opinion, is the evolution of that thing in the enterprise Ethereum alliance context to take it to the private domain. I used to go around saying, JP Morgan's quorum is the basis for that because that's what they said a year ago. But in the meantime, I've heard all sorts of stuff has happened both at JP Morgan and at EEA. So I'm anxious to hear from my buddy here what is going to be announced in the near future. I believe in consensus there'll be a full-blown announcement in the next couple of weeks in New York as to what really is the story with where EEA is headed and so on. In terms of the Hyperledger consortium, it came into existence about 2.5 years ago when IBM contributed source code and made it an open source project under the Hyperledger, under the Linux Foundation. That was just the first project. There are now many projects under that Hyperledger consortium. There isn't an attempt to have only projects which are mutually compatible. In fact, you will hear about Sawtooth, which is an Intel-initiated one, which also is a project under the Hyperledger consortium. There are many players here, but the specific thing that I've described here is the version 1 of the Fabric system, which is the one that I know most about. There's been a significant change from the 0.6 release to the 1.0 release, where the notion of endorsing peers was introduced. There are now two kinds of peers: regular peers, which are not having the smart contract installed in them, and the endorsing peers, which do have the smart contract installed in them. This was introduced as a way of improving parallelism and scalability and all that. Also, the notion of channel was introduced. So if you have in the same network Walmart and Safeway and their suppliers, Walmart doesn't want Safeway to see what is the traffic that Walmart is generating, who it's interacting with amongst its suppliers and so on. And so that's why the notion of channel gives you the ability to have something like a Venn diagram amongst a set of entities where each blob in that Venn diagram constitutes a channel. So the smart contract, the state database, and the blockchain that are all associated with a single channel is completely disjoint from those associated with the other channels. This is the way that scalability is improved, as well as the trust is restricted, or I should say the visibility is restricted, and so you have better control over who gets to see what and things like that. In terms of other aspects, I'll just say that a key value store is what's being used to model the assets, which is not a very satisfactory, which is not a very good, easy to use kind of a way of modeling assets. So my current project is actually adding relational database support so that you can have the full power of SQL to model these assets, just like in any database application. Right now, it doesn't deal with Byzantine failures because they moved from using PBFT to just Kafka as a consensus layer. So it's a pub/sub kind of piece of software. Both the IBM blockchain platform as well as the Oracle announced not yet available blockchain as a service is based on this, as well as some of the Chinese ones. I'm not able to make out too much of the details of the Chinese ones because for the time being they seem to be targeting the Chinese market, so all their white paper and such are published only in Chinese. But my guess is that in due course of time, Baidu and such will also be announcing their blockchain as a service offerings based on Fabric version 1. So in other words, there is a lot of momentum behind this particular blockchain system. And more recently, version 1 of Sawtooth has been released, whereas the version 1 of Fabric has been around for a while now. In terms of how things execute here, this picture tries to characterize what happens when a client starts a blockchain transaction. It results in the smart contract on the server side being invoked with certain parameters. And while that thing executes, it will make accesses to the state database where the assets under management are stored persistently. And these will result in certain reads being performed. and certain writes being attempted, but they are not performed at that stage. This is what's called the simulation of the blockchain transaction. This results in a set of write items and read items being generated, which are sent back to the client. So more details are in this slide. So the client submits the same transaction to multiple endorsing peers. This is in some sense like the priest asking the groom and the bride, are you willing to marry kind of thing, and then gets back the result. So in that sense, the client receives back at the end of step 1, the read and write sets as generated by the different endorsing peers to which it submitted the transaction. No change has been made so far. Nothing is recorded persistently. These things are sent back to the client, who compares, and if there is agreement, sends the transaction with all the signature and everything, the read and write sets, to the ordering service, which receives many such transactions, puts them into a block, a newly created block, sends it to all the nodes now, including the original guys, because they don't have any memory of such transactions that they simulated. Each guy, after receiving a block, steps through the transactions in the block one at a time, pulls out for each transaction its read set, looks into its database to see if any of those items have changed since then. If they haven't, that means validation has succeeded. For those of you knowledgeable about databases, this is like optimistic concurrency control. Under those conditions, then it takes all the write set data and dumps it into the database. And that constitutes a successful execution of a blockchain transaction. If the validation fails for any reason, because some item that was read has been meanwhile changed between the time of the simulation and now, then such a transaction's updates are not installed, and that's a loser transaction. This, in a gist, is how, in the case of Fabric, a blockchain transaction execution takes place. Okay, R3 Corda is another blockchain system that's been around. They make use of relational database system. It was developed mostly by financial institutions working together. So it has many of the characteristics of Ethereum and so on as part of it, the UTXO model and things like that. So it's a very specialized thing where in the conceptual model itself, they have more elements that mimic how money transfers and such things happen, bond contracts and such things. And a lot of these kinds of systems require that the smart contracts be deterministic, because in parallel they'll let multiple nodes execute the same thing. And if you toss a coin or look at what the current time is and all that, these different nodes can come up with different values, and hence the end result won't be the same in all the nodes. Sawtooth I've already talked about a fair bit. I'll let my buddy later on in the panel say more about it. But in a gist, it's leveraging Intel's secure execution environment. I believe it's based on Ethereum. I'm also eager to hear the greater details about this. This is the project I mentioned before, where I and my colleagues are working on adding relational database support. So if you look at this picture, this is where the main difference is. It used to say get, put, delete, very simplistic kind of constructs, whereas now by having the full power of SQL there, including invoking stored procedures and such, performance can be much better, but more importantly, errors will be less likely, and also you'll be able to do analytics in place in the state database itself. You don't have to extract the data, shove it into a warehouse and things like that, as in a traditional age-old way of doing business. This will promote the idea of hybrid transactional and analytic processing, where against the latest state of affairs, you can do analytics. And in due course of time, the relational DBMS stores also the past states. You will be able to do analytics and do time walk queries and all that, even on the past states of the assets and so on. And you can also measure things like how long did it take for the diamond to go from the time it was mined to somebody getting a ring on her finger and things like that. Okay. In terms of lots of futuristic things that need to be worked on, in the blockchain space, we are like where we were 40 years ago in the case of relational database systems, meaning the systems have certain features and so on. The users are left to their own devices to figure out under what condition which feature to use. I told you about how the client gets to decide how many endorsing peers it should submit the transaction to and such things. We don't give you a whole lot of help right now. We don't have the equivalent of the IBM Red books, which are like guides for people to develop their applications and such. Relational database systems, long after they came out, is when things like indexing advisor and partitioning advisor and all these kinds of tooling got developed, with BMC and various companies also coming into existence purely to develop such tools. So such an ecosystem still needs to be developed in the concept of blockchain systems. There are also other issues like how you go from English language contracts to more formal looking things against which properties can be proven, which is similar to, in some sense, Petri nets and such that used to be the case with workflow systems, for instance. And then to go from such a formal model to an executable contract. How much of this can be automated is all interesting research problems that are being worked on as we speak. Of course, there are no standards, as I said before. You might hear about COCO framework and such from Microsoft, but it's still not an attempt to provide you a single API and then let that thing go and worry about the specific APIs of the different blockchain systems and such. Things like what we did in the database area with heterogeneous data integration and such, one might want to do here, but those are all still things to be done. And also when you have the notion of channel, today, for instance, a particular transaction, blockchain transaction, is restricted to working on a single channel. We do allow you to refer to data in other channels, but only for read purposes, and they are not subject to the validation that I talked about. So if you want to do even updates across two channels, that involves two-phase commit and all that, that's just not supported today. So there are many such interesting topics to be worked on. So if you're a researcher or a student or a startup trying to come up with some proposal for doing some interesting work, there are lots of things that can be worked on. And that's it. Thank you.